So today we're going to start Unit 3, which has to do with polynomials. Before we begin Unit 3, I want us to go ahead and try some more basic polynomials that you probably remember from Math 1 and Math 2. So your Day 1 warm-up has to do with combining like terms. Combining like terms means adding together the terms that look alike. So if I'm looking at number 1, I see 2x plus 7x plus 9. And so my like terms would be 2x and 7x. And when I add together 2x and 7x, I would get 9x. And then I still have that plus 9 at the end. And number 2, I've got 3x squared plus 12x minus 18x minus x squared. So I've got a couple of different like terms. I've got 3x squared and negative x squared. And then I've got 12x and negative 18x. And so 3x squared minus x squared will give me 2x squared. And 12x minus 18x will give me negative 6x. In number 3, I've got negative x to the 5th plus 4x to the 5th plus 2x minus 3x to the 5th minus 2x plus 19 minus x to the 4th. So I've got like terms in my x to the 5ths, and then my x's, and then my 19 and my negative x to the 4th don't have like terms. So I'm going to start with my x to the 5ths. I've got negative 1x to the 5th plus 4x to the 5th, which will make 3x to the 5th, minus 3x to the 5th, which means all of those are going to cancel each other out. Next, I'll put my negative x to the 4th. So if you'll remember, that's what we call, when we put our exponents in order from highest down to where we don't have any, we call that standard form. And we'll talk more about standard form here in a little bit. So I've got negative x to the 4th. Next, I would do my 2x minus 2x, and those will cancel each other out. And then at the very end, I'll have plus 19. All right, now move on to your notes for Section 3.1. So in Section 3.1, we're going to be looking at combining functions. And so your essential question says, how do you combine functions through addition, subtraction, and multiplication to create new functions? So today, when we're talking about polynomials, keep in mind that you want to keep these in standard form. And so that's when your polynomial is ordered from the variable with the highest exponent down to the lowest. Your degree of a polynomial is going to be your highest exponent of a function when it's in standard form. So the good news is your degree should be, if it's in standard form, the exponent at the very beginning. All right, so when we name polynomials, we name them based on their degree and their number of terms. And so when we name based on the degree, you have linear, quadratic, cubic, and quartic. Those are your ones that you'll be most likely to see in Math 3. So a linear means that it has a degree. Remember, a degree is your highest exponent of 1. So an example of that would be something like x plus 2. A quadratic has a degree of 2. So if it's got an x squared in it, that would be an example of a quadratic. A cubic has a degree of 3. So as long as you don't have any exponents bigger than 3, you have a cubic. And a quartic has a degree of 4. When we name based on the number of terms, we are naming polynomials. And so that kind of gets confusing because whenever you look at the way that you can name, you've got monomial, binomial, trinomial, and then at the bottom you've got polynomial. And what's kind of confusing is that Monomials, binomials, and trinomials are still considered polynomials. So it's kind of like having a big umbrella where polynomial is the umbrella itself, and all of these, monomial, binomial, and trinomial, are underneath that umbrella. These are special types of polynomials. So a monomial is a polynomial that has one term. And so an example of a polynomial that has one term could look like something like negative 2x to the third y to the second z. So when we talk about number of terms, terms will be pieces of your polynomial that are broken apart by pluses and minuses. So if you see a plus or a minus, that indicates a new term. A binomial is a polynomial that has two terms. And so an example of that could be like x to the third minus 7y squared. So notice that it's got two distinct parts. It's got x to the third and it's got negative 7y squared. A trinomial is a special type of polynomial that has three terms. And so an example of that would be like x to the fifth plus 2x squared minus 14. And then if we have more than three terms, so basically if we've got 4 plus terms, we just call it a polynomial and it doesn't get any other special name. So an example of that could be like 7x to the fourth plus 6x to the third minus 5x squared plus 4x minus 3. All right, so in the next examples, what we're going to do is look at each of these polynomials. We're going to check to see if it's in standard form, which means that they are in order from highest exponent down to where you don't have any. You're going to see how many terms you have, what the degree is, and then you're going to actually name that polynomial. So when you look at number 1, you've got negative x cubed plus x to the fourth plus x. So whenever you look at it, look at your exponents first to see if it's in standard form. So you've got an exponent of 3, an exponent of 4, and then this x to the first power. So x to the fourth would be your highest exponent, and so because it's not at the front, that means it's not in standard form. To write it in standard form, we'd move that x to the fourth to the front, and then we would put negative x cubed, and then we would have plus x. So it's basically just rearranging so that you've got your term that's got your highest exponent at the beginning. On this one, we can see 3 distinct pieces. We've got our x to the fourth, we've got our negative x cubed, and we've got our positive x. So this has 3 terms. This polynomial has a degree of 4, and we know that because we know it's in standard form once we've rewritten it, and our highest exponent is 4. If we wanted to name this polynomial, we could call it a quartic because the degree is 4, trinomial because it has 3 terms. In example 2, we've got 5a squared plus 3a cubed plus 1. So to see if it's in standard form, you're going to look at the exponents and see if they're in order from greatest to least. So I've got an exponent of 2, I've got an exponent of 3, and then this 1 at the end is a constant. So my exponent of 3 is not at the beginning, so if I'm going to write it in standard form, I have to put 3a cubed first, because that's my term with my highest exponent. And then I'm going to put plus 5a squared, and then plus 1. So my number of terms is going to be 3, because I've got 3 distinct pieces, the 3a to the third, the 5a squared, and the 1. My degree is also going to be 3 because my highest exponent was 3. So to name this one, this would be a cubic trinomial. On example 4, you've got 3 plus 12x to the 4th. So this one, I've got a constant number, and then I've got my 12x to the 4th. 12x to the 4th obviously has my highest exponent, so that's the piece that needs to become, or to go to the beginning if I'm going to write it in standard form, and then I'll have my plus 3 at the end. If your polynomial is in standard form, your constant, if you have one, should always be at the end of your polynomial. And remember, your constant is your term that does not have a variable. So for number of terms, it's clear that I've got just two pieces to this one. I've got 12x to the 4th, and then I've got my positive 3. My degree is 4, because my highest exponent was to the 4th power. And so to name this one, it would be a quartic. Quartic because my degree is 4. Binomial because I have two terms. In example 4, I've got 7x to the 3rd minus 10x to the 3rd plus x to the 3rd. So this one I can tell that I actually have some like terms. And I know that those are like terms because they have the same variable with the same exponent. So I'm actually going to put together the 7x to the 3rd, the negative 10x to the 3rd, and the positive x to the 3rd. So 7 minus 10 would give me negative 3. Negative 3 plus 1 would give me negative 2x to the 3rd. So with my negative 2x to the 3rd, now in standard form, my number of terms would only be 1 because there's only one piece there. And my degree would be 3 because that's my highest exponent. To name this, this would be a cubic because it's got a degree of 3. Monomial because it only has one term. Moving down to the bottom, it says when combining functions, you may see a variation of the following. So we've talked about functions. We already know what those are. So if we want to combine functions, we can do that with addition, subtraction, multiplication, or division. And so when we've got our functions, remember if it says f of x or g of x or h of x or whatever, that means it's in function notation. So what we might see is we might see our function notation for f plus a function notation for g. So this would represent two different functions that we were adding together. Another way that we might see addition is we might see f plus g of x. With subtraction, I've got f of x minus g of x. So my function f of x minus my function that represents g of x. Or you might see it written f minus g of x. With multiplication, you might see f of x times g of x, or f times g of x. And with division, you might see f of x divided by g of x, or f divided by g of x. This means the same, this means the same, this means the same, and this means the same. It's just kind of depends on what your problem looks like. So on example 6, it says solve the following problems given the functions below. So you've got f of x equals negative x plus 4. You've got g of x equals x minus 1. H of x equals x plus 5. M of x equals x squared plus 2x plus 1. N of x equals 3 times x cubed minus 3x squared plus 3x minus 1. And P of x equals 3x plus 1. So in number 1, it asks us for f of x plus g of x. So if it asks us for f of x plus g of x, my f of x is negative x plus 4. And my g of x is x minus 1. So what I'm going to do is replace f of x with what f of x is equal to, which in this case is negative x plus 4. And I'm going to replace g of x with what g of x is equal to, which is x minus 1. So in order to combine those together, I would need to get rid of those parentheses by putting my ones out front and distributing, just like you would have done back in Math 1. So you'll get negative x plus 4 plus x minus 1. And then you would look to combine your like terms. So your like terms in this case would be your negative x and positive x, and then your 4 and negative 1. So the negative x, positive x would cancel each other out, and 4 minus 1 would just give you positive 3. In number 2, you're doing f of x minus h of x. So I would start with my f of x, which we know is negative x plus 4, minus h of x, which is x plus 5. I'd put my ones out front and distribute so I can get rid of those parentheses. I'd have negative x plus 4. Negative 1 times x gives me negative x, and negative 1 times 5 gives me negative 5. I would combine my like terms. My negative x and negative x, and then my 4 and negative 5. So negative x minus x gives me negative 2x, and 4 minus 5 gives me negative 1. For number 3, I've got f of x plus p of x. So I know f of x is negative x plus 4, and p of x is 3x plus 1. I put my ones out front and then distribute. So 1 minus x is negative x. 1 plus 4 is positive 4. 1 plus 3x, or 1 times 3x is 3x. 1 times 1 is positive 1. Then I would combine my like terms. Negative x and positive 3x, and positive 4 and positive 1. So negative x plus 3x will give me 2x, and 4 plus 1 will give me 5. In number 4, I've got g of x plus h of x. So my g of x is x minus 1, and my h of x is x plus 5. Put my ones out front and distribute. 1 times x is 1x. 1 times negative 1 is negative 1. 1 times x is 1x. And 1 times 5 is positive 5. I'll combine my like terms, which will be my x and my x, my negative 1 and positive 5. So x plus x will give me 2x, and negative 1 plus 5 will give me positive 4. In number 5, I've got m of x plus g of x. So my m of x is equal to x squared plus 2x plus 1. My g of x is equal to x minus 1. I'll put my ones out front and distribute. So 1 times x squared is x squared. 1 times 2x is 2x. 1 times 1 is 1. 1 times x is x. And 1 times negative 1 is negative 1. Combine my like terms. So my 2x and my x. And then my positive 1 and my negative 1. When I go to write my answer, remember my x squared needs to come first because it's got the highest exponent, and I always want to try to write it in standard form. My x squared also didn't have any like terms, so it stays by itself. Then I've got 2x plus 1x, which makes 3x. And my 1 and my negative 1 will cancel each other out. So I've just got x squared plus 3x. And number 6, I've got n of x plus m of x. So my n of x is 3x cubed minus 3x squared plus 3x minus 1 plus my m of x, which is x squared plus 2x plus 1. I'll put my 1's out front and I'll distribute. So 1 times 3x cubed is 3x cubed. 1 times negative 3x squared is negative 3x squared. 1 times 3x is 3x, and 1 times negative 1 is negative 1. 1 times x squared is x squared. 1 times 2x is 2x, and 1 times 1 is positive 1. I'll combine my like terms by saying I've got like terms in negative 3x squared and positive x squared, positive 3x and positive 2x, and then negative 1 and positive 1. When I begin my solution, though, my 3x cubed needs to come first because it's got my highest exponent. Then I would deal with my x squared, so my negative 3x squared and positive 1x squared, which will give me negative 2x squared. My 3x plus 5 or 2x will give me 5x, and then my negative 1 and positive 1 will cancel each other out. On number 7, I'm doing m of x minus g of x. So my m of x is x squared plus 2x plus 1 minus my g of x, which is x minus 1. I'll put my 1's out front and distribute. So you'll have x squared plus 2x plus 1 minus x plus 1. And then you'll combine your like terms. So your 2x and your negative x, and your positive 1 and positive 1. X squared doesn't have the like term, but remember he needs to go first because he's got the highest exponent. Then 2x minus x will give you positive x, and 1 plus 1 will give you positive 2. Number 8, I have to do g of x times f of x. So back up here at the top, I find out that f of x is negative x plus 4. So I'm really going to do negative x plus 4 times x minus 1. So because I'm doing multiplication and I'm multiplying two binomials together, I'm going to draw myself a box and label my box. So I've got negative x and positive 4, x and negative 1. So when I multiply inside my box, negative x times x gives me negative x squared. Negative x times negative 1 gives me positive x. 4 times x gives me 4x, and 4 times negative 1 gives me negative 4. That point, I'll take all of my terms out, so negative x squared plus x plus 4x minus 4, and then I'll combine my like terms. So my like terms would be my x and my 4x, and that would give me negative x squared plus 5x minus 4. On number 9, I've got g of x times m of x. So my g of x was x minus 1. My m of x was x squared plus 2x plus 1. So in this one, I've got a binomial times a trinomial. So that means I'm going to have a 2 by 3 box. So I'm going to put x and negative 1 down the side, and across the top I'll do x squared, 2x, and 1. So x times x squared is x cubed. X times 2x is 2x squared. X times 1 is x. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times 1 is negative 1. So then I'll write down everything from the box. X cubed plus 2x squared plus x minus x squared minus 2x minus 1. And then I'll combine my like terms. So my like terms would be my x squareds, and then my x's. My x cubed doesn't have a like term, but it needs to go first because it's got the highest exponent. 2x squared minus x squared would go next, so that would be plus x squared. X minus 2x will give me negative x, which will come next. And then my constant negative 1 should be at the end. Let's go back quickly to the beginning and let's name each of our answers. So on number 1, we only had one term. That was a term that did not have a variable. And so this is actually what we call a constant because it doesn't have a variable. And because it's got one term, it'll be a monomial. So this is a constant monomial. In number 2, my degree is 1. So that means I have a linear. Because I've got two terms, that makes it a binomial. In number 3, I've got x to the first power, which makes it a linear. Two terms, which makes it a binomial. Number 4, I've got x to the first power, which makes it linear. Two terms, which makes it a binomial. Number 4, my highest exponent is 2, which makes it a quadratic. Two terms, which makes it a binomial. Number 6, my highest exponent is a 3, which makes it a cubic. I've got 3 terms, which makes it a trinomial. Number 7, my highest exponent is a 2, so that makes it a quadratic. 3 terms, which makes it a trinomial. Number 8, my highest exponent was a 2, which makes it a quadratic. 3 terms, which makes it a trinomial. Number 9, my highest exponent is a 3, which makes it a cubic. I've got 4 terms, which makes it just a polynomial.